Welcome back, everybody. So we're jumping into Chapter 2, Section 5. We're going to discuss cross multiplication in a little more detail. I know I've alluded to it in previous videos, but I thought it would be good to actually spend some time on it alone. Now, before we dive into the mechanics of cross multiplication, I want you to understand the difference between a ratio and a proportion. So how are those two alike and how are those two different? Okay, now a ratio is a comparison of two numbers generally by division. That's how we define a ratio. So what you'll do is you'll see that written as maybe A over B, or say 1/2 or 2/3. There are other ways to do it. You can write it out in words, A to B. Okay, that's also a form of a ratio. It doesn't fit in equations well, but it's another way to do it. You also have A to B's. So these are all three different ways to show a ratio, but only one of them fits into an equation, and that's where you write it as kind of a fraction, A over B, or A divided by B. Now, comparing that to a proportion is where you take two ratios and you set them equal to each other. So we could do 3 over 7 equals 6 over 14. So that compares two ratios, in this case fractions, and we can see that 3 over 7 is in fact the same as 6 over 14 if you just multiply top and bottom by 2. Now, algebraically what that looks like is A over B equals C over D. So this is a ratio, but this is a proportion. You can see a proportion is actually an equation. Okay, now how does that all fit into cross multiplication? Well, let's take a look at that. So here I've got that same fraction, 3 over 7, equal to the same fraction, 6 over 4. So this is a proportion. What is unique about cross multiplication is I can take what are known as the extremes and multiply them together like that. So I've got the numerator on the left side times the denominator on the right side, and I'm going to set it equal to the denominator on the left side times the numerator on the right side. So I've got 3 times 14 equal to 7 times 6. You could write it the other way around. I could have had 7 times 6 equals 3 times 14, doesn't matter. But you see that what you get is 42 equals 42. And that's always going to be the case where when you cross multiply, the two sides of the equal sign have to be equal to each other. Algebraically, what that looks like is this. When you go to cross multiply, you get A times D equals B times C. Okay, so that's how ratios, proportions, and cross multiplication all fit together. Now let's take a look at how we can use that in a problem to solve for variable, or to solve an equation. So let's say I had a very simple one. 8 over x equals, no, how about x over 8? This is supposed to be an 8, sorry about that. X over 8 equals 5 over 6. Okay? We can use cross multiplication to figure out what x is. We multiply the extremes. Okay, so x times 6, or 6x, equals 8 times 5. So that's 6x equals 40. And then divide both sides by 6. 6's cancel, you're left with x. X equals 40 over 6. And if I reduce that down, that is 6 2/3. So that's how we can use cross multiplication in actually solving a problem. Let's take a look at another fairly simple example. I'll put this page aside. So I'm going to page 2 of, and we'll do example garlic. And today's category is types of bread. Okay, so let's do y over 12 equals 4 over 7. Okay, and we're going to cross multiply. y times 7 is going to be equal to 12 times 4. So I've got y times 7, just write 7y equals 12 times 4. If I multiply the 12 and the 4, I get 7y equals 48. And then I can divide both sides by 7. And I get y equals 48 over 7, which reduces down to 6 6/7. Okay, so there's another fairly basic example. Now we can use cross multiplication to actually solve real-world problems. So let's take a look at example, what's another kind of bread? Oh, well, let's say we've got types of toast: French toast, garlic toast. You can also have burnt toast. Okay, anyway, if my car goes 35 miles on 1 gallon of gas, how far will it go on 2.5 gallons? .5 gallons. So this is a real-world type of problem. And what I'm going to do is set up a ratio first that compares gallons and miles, or miles and gallons. So I'm going to choose to do miles over gallons. Okay? So that's a common ratio. You often hear people talk about how many miles per gallon their car gets. So that's why I chose miles over gallons instead of gallons over miles. You could do it either way, you'd get the right thing. Now, from the problem, I know I get 35 miles for 1 gallon. So my first ratio is 35 miles in 1 gallon. Notice miles on top, gallons on the bottom. Equals, now I have 2.5 gallons, but I want to know how far it's going to go. So how far will it go? That's my variable. That's my x, my unknown. So that's going to be x up here, and I go 2.5 here. So how far I go, miles in the numerator, over 2.5 gallons in the denominator. And you can see I can use cross multiplication now. 1 times x, 35 times 2.5. So 1 times x is x equals 35 times 2.5. And if I work that out, x equals, what is that, 87.5? So on 2.5 gallons of gas, I can go 87.5 miles. So that's how we can use cross multiplication in an actual problem, in an actual real life situation. Now, I want to step it up a little bit in terms of the complexity of the problems. So let's do example, it's another kind of toast, buttered. So we've got buttered toast. Now, watch how this one's different. I've got x plus 4 over 5 equal to x minus 2 over 7. Notice the difference is now I've got the variable x on both sides in multiple locations, but it doesn't change the process. I'm still going to use cross multiplication. 5 times x minus 2 and x plus 4 times 7. So I've got 5 times x minus 2, note the use of the parentheses, equals 7 times x plus 4. All right? You got to use the parentheses because that 5 is being multiplied by both the x and the minus 2. All right, so you know what to do here at this point. You're going to distribute the 5 and you're going to distribute the 7. So you get 5x minus 10 equals 7x plus 28. Now, got to move the like term or the variable terms together. I'm going to subtract 5x from both sides. I did it this way so I'd have a positive 2x over here. Well, the 5x and the negative 5x, those cancel. I bring down a negative 10. I'm very careful to bring down the negative. Equals 2x. Again, notice the 2x is positive. Plus 28. Now I'm going to subtract 28 from both sides. And I get negative 38 equals 2x. And then I just divide both sides by 2. And the 2's cancel. I'm left with x equals negative 19. So that stepped it up a notch. You can see it's a little bit more complicated. You've got multiple steps to get through the problem. Again, notice how I'm bringing everything down. I'm not doing chicken scratching all over the place. It's very methodical, and anyone could look at this and kind of follow what I did.